All right, let's talk about something huge for AI. You know how powerful large language models are, but they're also incredibly expensive and slow to run? Well, Microsoft just unveiled something called WINA. It's a new method that could make running these massive AI models significantly faster and cheaper. We're talking over 60% less compute cost, all without sacrificing accuracy. This is a game changer. So what exactly is WINA? It stands for Weight-Informed Neuron Activation. Essentially, it's a brand new method developed by Microsoft and a team of researchers to tackle that huge computational cost problem with large language models. The core idea is pretty clever. Instead of making the entire AI model work hard on every single task, WINA figures out which parts, which neurons, aren't really needed for that specific moment and lets them take a nap. This dynamic gating drastically cuts down on the processing power required. In this video, we're going to dive into how WINA actually works, look at the impressive performance results they've shown, and discuss why this is such a significant step forward for AI efficiency. Okay, so why are these powerful AI models like LLMs such resource hogs? The main reason is that for every single query you give them, they essentially light up and use almost their entire massive network. Think of it like turning on every light in a huge building just to read a single page. It's incredibly inefficient in terms of power, time, and cost. Naturally, engineers have been trying to fix this waste. One approach is called mixture of experts, where you train specialized subnetworks, but training those is a huge, complex undertaking. Another path is training free methods, like TEAL, which try to shut off parts of the model while it's running. These often just looked at how loud a neuron's signal was, silencing the quiet ones. The problem? Some quiet neurons are actually really important, and just turning them off can hurt performance. This is where WINA comes in with its big breakthrough. Remember how previous methods like TEAL just looked at how loud a neuron was? WINA adds another crucial piece of information, the weight magnitude. Think of it like this. A neuron's activation is how loud it's shouting, but the weight magnitude is how big a megaphone it's using. A neuron might be shouting loudly, but if its megaphone, its weight, is tiny, its signal doesn't actually carry much influence down the line. WINA's genius is that it considers both factors. It essentially multiplies the loudness by the megaphone size to get a better measure of a neuron's true impact at that specific moment. Based on this combined score, WINA dynamically decides which neurons are truly essential for the current task and lets the others take a temporary, quote, nap. This is a much smarter way to identify and switch off unnecessary parts of the network on the fly. So how does this smart nap schedule translate to real-world performance? The researchers tested WINA on several major models, including Llama 3 and 5.4, using standard benchmarks. The results are pretty impressive. When they pushed WINA to shut down a significant portion of neurons, we're talking 65% or more, it consistently maintained higher accuracy than previous training-free methods like TEAL. On models like QN 2.5 and 5.4, WINA was several percentage points better, and with Llama 3, it pulled ahead once they went past 50% sparsity. But here's the really big deal. Cutting those neurons drastically reduces the raw computation needed, measured in flops. At 65% sparsity, they saw compute reduction hovering around the 60% mark across different models. For example, on Llama 2, flops dropped from 6.6 billion down to 2.4 billion. This massive reduction in computation translates directly into huge cost savings for anyone running these models at scale, potentially cutting GPU bills in half. Beyond just the raw performance numbers and cost savings, WINA has some really practical advantages. One of the biggest is that it requires zero extra training or fine-tuning. Unlike other methods that might need you to retrain the entire model after making changes, WINA is essentially a plug-and-play solution. You can just add this gating mechanism to an existing model and start seeing the benefits immediately. This is also where the dynamic nap concept is key. WINA isn't like classic pruning, which permanently chops off parts of the network. Instead, it just lets neurons take a temporary break on each forward pass. This means the full model capacity is still there, ready to be used if needed for a trickier input. Plus, the code for WINA has been open sourced by Microsoft, making it accessible for anyone to use and experiment with. So to sum it up, Microsoft's WINA is a significant step forward. By intelligently letting unnecessary neurons nap based on both their signal and influence, it makes large language models dramatically more efficient and cost-effective, cutting compute by over 60% without needing retraining. This makes powerful AI much more practical for everyone. Share your thoughts in the comments. Hit subscribe to get notified when new AI discoveries drop. Thanks for watching.